We're finally here. We've been doing exponentials for a heap of time, and we haven't found a single x-intercept. So let's do it. Let's find the x and y-intercept and do a full sketch. So let's start off. And notice it says exact values, which means we're not going to be rounding these as decimals, if there's any need to. So when we're looking for the y-intercept, well, that's when x equals 0. And we get f of 0 is equal to negative 5 to the 0 plus 2. Question is, order of operations. Is negative 5 to the 0 1 or negative 1? Well, the indice happens first, so we get negative 1 plus 2, which is 1. So there is our y-intercept, 0, 1. For our x-intercept, that is going to be when y equals 0, or in this case, f of x equals 0. So we get 0 is equal to negative 5 to the x plus 2. Take 2 from both sides. Minus 2 is equal to minus 5 to the x. And before we try to do any logarithm stuff, let's cancel out these negative signs. So you can think about it as dividing by negative 1, or you can just think about them cancelling on both sides, but this is equal to 2 to the 5 to the x. Now we're going to use our log rule. So since we've got log base 5, because we've got a base of 5. And that's going to cancel that on the right-hand side. And we get our answer is x is equal to log base 5 of 2. So that means we've got this point here, log base 5 of 2, comma, 0. And those are our two intercepts. Now, just as a reminder, because we've got this plus 2 here, that means that our asymptote is going to be y equals 2. Now, again, if you're unsure about the reflections and stuff, you can see there's a negative here, which means that there's some kind of reflection going on. The question is, what sort of reflection is actually going on? But let's just sketch what we know and see if we can work it out from there. So here's my axes, y equals 2. My asymptote. I've got the point 0, 1 as my intercept. And now the question is, where the heck is log 5 of 2? Well, this goes back to what we were trying to do before. How do we work out how big this is? Well, let's think about logs that we do know. So log base 5, what's a number that we do know? Well, we know log base 5 of 5. And we also know log base 5 of 1. And if you can't remember why we know that, it's important for us to remember that the log base 1 of log of 1 is always going to be 0, because the only way you get 1 with an index is if that index is 0. You can also think about it as this is 5 to the 0, so it's going to be 1 either way. So that means log 5 of 2 needs to live somewhere between these two values, and those two values are 0 and 1. So it's got to be somewhere between 0 and 1 on the x-axis, which is between here and here. So let's put a marker somewhere in between. Now, from this is actually enough to actually sketch the function. Why? Because we know it needs to either come this way and then go out, or it needs to do the opposite, come this way and then go out. But you notice if we go that way, it can't hit both points. Either it hits that point or it hits that point. There's no way for it to do like a zigzag and get both. So it's going to have to be asymptote on this side and then out this way. And there's our function. So it's asymptotically approaching that y equals 2 line. We've got our 0, 1 y-intercept. We've got our log 5 of 2, 0 x-intercept. And now I've just got to finish up my labels. X, Y, label a function, f of x equals negative 5 to the x plus 2. And indeed, we can see it's been an x-axis reflection as it is now pointing down. The only other thing we want to do is do our domain and range. So we're saying x has to be in the real numbers, and y, well, y does have a restriction. It cannot be bigger. In fact, it'll never be bigger than 2. And on the low side, there's nothing limiting it, so it'll be negative infinity. So it'll be somewhere between negative infinity and 2 is our range. And there we go. There's our full completed sketch. Let's have a look at one more. Alrighty, x-intercept when y-intercept when x equals 0. Order of operations is do the indice first, but inside the indice is subtractions. We're going to do the subtraction first. What is 2 to the negative 2? Well, it's actually 1 over 2 to the 2 minus 3. What's 1 over 2 to the 2? Well, it's 1 over 4 minus 3. Well, not 3. Let's write that as 12 over 4. Times it by 4 on top and bottom. And this is going to be minus 11 on 4, which, again, if we want to estimate this for sketching purposes, that is in between negative 2 and negative 3. Alrighty, now let's do our x-intercepts. Well, that's when y is equal to 0. We get 0 is equal to 2 to the x minus 2 minus 3. Add 3 to both sides. Take log base 2 of both sides. That cancels out the 2's, so we're just left with x minus 2 on the right-hand side. Add 2 to both sides. And once again, we run into this problem of what the heck is log 2 of 3 plus 2? Or at least approximately how big is it? So let's do the same trick we were doing before. So let's put borders on either side. So log 2 of 2, well, we know that, and log 2 of, well, the next power of 2, which is log 2 of 4, 2 to the 2. So it's got to be in between those two. Log 2 of 2 is 1. Log 2 of 3, and then log 2 of 4 is 2. So it's somewhere in between those two, but again, we want to add 2, so let's add 2 to everything. 3 and 4. So it's got to be somewhere between 3 and 4 when we're sketching it. So that's kind of giving us a bit of an idea of where we want to put it. Only other piece of information we need to know is our asymptote is going to be y is equal to negative 3. And now we're good to go. X is 1, X is 2. Let's label them X and Y first. I usually leave it to the end. Alrighty, asymptote y equals negative 3. Next one, let's go with our y-intercept, which is at negative, it's negative 11 on 4, which is going to be pretty close to negative 3. So it's going to be about here. So that point there, 0, negative 11 on 4. It's our y-intercept. Our x-intercept on the other hand is in between 3 and 4 on the x-axis. So 1, 2, 3, 4. It's going to be somewhere in between those two. And if you have a look at the function, there's actually no negatives in front of the 2 or in front of the x, meaning it has not been reflected in any way. So we're just going to get the standard shape. And again, our 2 points actually confirm that for us. If you weren't sure, you could sub in a couple of extra points just to be 100% certain. This is y is equal to 2 to the x minus 2 minus 3. Domain and range. I haven't actually marked this point yet. Sorry. Let me mark this point. This would be, what was it? Yeah. Log 2 of 3 plus 2x. And is there anything else I need to do? Oh, domain and range. X is in double R, all the real numbers. Y. Now, y cannot be smaller than negative 11 on 4. and it's got no upper limit, so up to infinity. Alrighty, and there we go. There is a couple of sketches doing the full shebang in one go. Alrighty, I'll see you in the next one. Goodbye.